If you're tuning into problem number 10, hopefully you also turned into problem number 9. You'll see some similarities here. First of all, you'll see that we've got two different logs and that these logs are on the same side, but the difference between 9 and 10 is that 10 doesn't have a log on the other side. It just has a regular number. So how would I start this? Well, we want to put those two logs together. We cannot cancel them. And we can't cancel them because they're on the same side. We want to put them together. We want to condense those logs into one log. All right, so I'm going to put those logs together. We're going to leave that one alone over on the other side. Well, how do I put those together? And I've already highlighted it here. It comes from that plus sign. There's the warning flag. There's the warning bell. Boom. That plus sign doesn't mean we're adding these two things. It actually means that we're multiplying those two things. So we're going to take that x plus 4 and we're going to multiply it with x minus 1. So addition of logs means multiplication of the arguments. Notice how I multiply these. So this plus sign tells me to multiply these two things. That's one of our rules. You can find that in our notes. And so if I do that really quickly in my head, I get, let's see, I'm going to use the box or FOIL method by doing this. I get 4x minus 1. That's going to be a plus 3x minus 4. Shame on me for not showing my work. You do have to show your work. Okay, now this is the crux. This is where we've got to make a decision. We've only got one log. What do I do? How do I get rid of it? It's got to go away. And so some people just made it go away and they just erased it because they're like, let's just set the rest equal to each other. That's not how it's done. We can't cancel them. And so we've got to have a different move when we only have one log. When there's only one log remaining, as in this case, convert that log to exponential form to actually get rid of that log. How do I do that? Well, here's my base, 6. Here's my exponent, 1. And then we can set the answer, the argument, equal to that. That's how we convert back and forth. And so now we can start solving here. Should I use inverse operations? No, this is a quadratic. How do I solve quadratic equations? You can use a quadratic formula. That would suck. Okay, or we can try factoring, perhaps better. So let's get this equal to 0. Because that's what we do with quadratics. And let's actually check for some factors. I've got 1 and 10. I've got 2 and 5. 1 and 10 will not give me 3. 2 and 5 will if I subtract them, as long as the 5 is positive and the 2 is negative. All right, so we're going to call this x minus 2, x plus 5. Now remember, that's not the solution. That's how I'd get there. Set each one of these equal to 0. And I'm being super extra now to make sure that we remember this step. And we get x equals 2 and x equals negative 5. Let's see if you remember the last step in the last problem too. In the last problem, we had to check for extraneous solutions. These might be good, or maybe only one of them is good, or none of them are good. Remember that when you have a log, the inside has to be positive. Okay, so that doesn't mean that negative is exactly wrong right away. We have to go plug it in to check it out. So I've got x plus 4 and I've got x minus 1 that I've got to check for. Let's see. Okay, so if I plug in 2 to each one of these, that gives me a positive. That gives me a positive. 2 is good. What about negative 5? If I plug in negative 5, what's that give me? That gives me a negative 1. That's not good. So negative 5 is extraneous. 2 is the only solution here. So you could have done all of this work, but if you don't check, still going to get it wrong. You got to check for negative logs. You got to check for extraneous solutions. Let's go through this process super quickly. I condensed my logs together by adding multiplication of those arguments. The log didn't just disappear after a FOIL or box method. I had to convert to exponential form, 6 and 1 equals, and then I solved by setting it equal to factoring. And of course we check because the inside needs to be positive.